To accurately measure a laser beam, Spiracon's BeamGage software eliminates everything from the measurement except energy from the laser beam. For example, ambient light, temperature changes, and electronic noise affect the signal intensity from the camera. BeamGage with Ultracal significantly reduces the noise that can alter the measurement of your laser. We have set up a test bench with a green helium neon laser and an SP928 camera with BeamGage Professional. The beam is attenuated with an assortment of ND filters. We will first measure the beam energy with an Ophir Vega power meter by placing a sensor in the beam path. We block the beam to zero the offset on the meter. Unblocking the sensor shows the attenuated beam contains 1.6 microwatts. When we remove the ND filters, the beam measures 160 microwatts, 100 times more powerful. We will now perform Ultracal on the camera with the beam blocked. When we remove the block, BeamGage measures the beam width at 2.2 millimeters. Moving the ND filters in front of the beam attenuates the laser energy by a factor of 100. The camera can barely detect the weak beam. Measuring the attenuated beam is difficult, as any noise in the system will overwhelm the weak beam. BeamGage offers a feature called frame summing. This allows a select number of frames to be compiled or summed to build up the image to one that is visible yet still representative of the laser source beam. When we sum 100 frames without Ultracal, we are summing the laser energy and system noise. We see an image, saturated to the point that no beam measurements are possible. By removing background noise with Ultracal, then summing 100 frames, the beam becomes very similar to the unattenuated beam. BeamGage measures the summed beam width equal to our previous measurement with no attenuation, showing that the Ultracal feature balances the camera noise component so that there is very little or no additional noise present when the image is summed 100 times. This is because Ultracal balances the noise, so there is as much negative noise as there is positive noise. If summed, an Ultracal frame with no signal, all the pixel values will be equal to or very close to 0. Because of this, we can differentiate between the laser beam and the camera noise. That is the magic of Ultracal. Other beam profiling products use less sophisticated algorithms that perform a baseline subtraction but truncate the noise below the zero of the baseline. This leaves only a positive component, which adds a net value to all beam measurements. Ultracal is the only beam profiler algorithm that sets the baseline to 0 and in the center of the noise. It is no surprise that Spiracon's Ultracal helped establish the ISO 11146-3 standard for beam measurement accuracy. Measuring your laser has never been easier. To discuss your laser application with a sales engineer, contact your local Ophir Spiracon representative or visit us on the web at ophiropt.com/photonics. Ophir Spiracon, the true measure of laser performance.